Good morning, students. In this video, we are going to discuss about a transport level security continuation, HTTPs and SSH. First, we will discuss about HTTP, then we can move on to the SSH. What actually HTTP? The Hypertext Transfer Protocol, which provides the transfer service for a web client and a web server interaction, and it can be operate on top of SSL. Today we are going to discuss about this HTTP over SSL. HTTP refers to the combination of HTTP and SSL to implement a secure communication between a web browser and a web server. The HTTP capability is built into all modern web browsers. Its use depends on the web server supporting then HTTPS communication. For example, some search engine do not support HTTPS. Google provides HTTPS as an option where HTTPS colon / double / google.com. The principal difference seen by a user of a web browser in that URL address being with HTTPS rather than the HTTP colon / A normal HTTP connection uses a port 80. If HTTPS is specified, the port 443 is used, which invokes SSL. When HTTPS is used, the following elements of the communications has to be get encrypted as an URL of the requested document, content of the document, content of the browser forms, and cookies sent from browser to server and from server to browser, and the contents of HTTP headers. And HTTP is documented in RFC 2818 has HTTPs over a TLS. There is no fundamental change in the using HTTP over either SSL or TLS, and both implementations refer to a HTTPS. Let's discuss about the uses of HTTPS. For HTTPS, the agent acting as an HTTP client also acts as the TLS agent. Client. The client initiates a connection to the server on the appropriate port and then sends the TLS client hello to begin the TLS handshake. When the TLS handshake has finished, the client may then initiate the first HTTP request. All HTTP data is to be sent as TLS application data. Normally, HTTP behavior, including retained connection, should be followed. There are three levels of awareness of a connection in HTTPS. At the HTTP level, an HTTP client requests a connection to an HTTP server by sending a connection request to the next lower layer. Typically, the next lower layer is TCP, but it also may be TLS or SSL. At the level of TLS, a session is established between a TLS client and a TLS server. This session can support one or more connections at any time. As we have seen, a TLS request to establish a connection begin with the establishment of a TCP connection between the TCP entity on the client side and the TCP entity on the server side. Such a way, the connection is going to be get initiated within the HTTPS. We'll move on to the next use, connection closer. An HTTP client or a server can indicate the closing of connection by including the following line in a HTTP record as connection colon close. This indicates that the connection will be closed after this record is delivered. The closure of an HTTP connection requires that a TLS close the connection with the peer TLS entity on the remote side. which will involve closing the underlying TCP connection. At the TLS level, the proper way to close a connection is for each side to use the TLS alert protocol to send a close notify alert. The TLS implementation must initiate an exchange of closure alerts before closing a connection. And a TLS implementation may, after sending a closure alert, close the connection without waiting for the peer to send its closure alert, generating an incomplete close. This should only be done when the application knows, typically through detecting an HTTP message boundaries, that it has received all the message data that it cares about. A HTTP client also must be able to cope up with an situation in which the underlying TCP connection is terminated without a prior close notify alert and without a connection closure indication. Such a situation could be due to a programming error on the server or a communication error that causes the TCP connection to drop. However, the unannounced TCP closure could be evidence of some sort of attack. So, the HTTP client should issue some sort of security warning when this occurs. Such a way, the connection is going to be get closed with the help of HTTPs. Let's move on to the next one. Secure Shell SSH. What actually an SSH? A secure shell is a protocol for secure network communication designed to be relatively simple and inexpensive to implement. The initial version SSH1 was focused on providing a secure remote login facility to replace Telnet and other remote login schemes that provided no security. SSH also provides a more general server client capability that can be used for such network functions as file transfer and email. A new version SSH2 fixes a number of security flaws in the original scheme. SSH2 fixes SSH client and server applications are widely available for most operating systems. So a new version SSH2 fixes a number of security flaws as we have discussed already, and this SSH2 is documented as a proposed standard in IETF RFCs as 4250 through 4256. It has become the method of choice for remote login and tunneling externally, and it's rapidly becoming one of the most pervasive applications for encryption technology outside of embedded system. Here the SSH is organized as three protocols that typically run on top of TCP as transport layer protocol, user authentication protocol, and connection protocol. What actually the transport layer protocol, which provides server authentication, data confidentiality, and data integrity with the forward secrecy. That is, if a key is comprised during one session, the knowledge does not affect the security of earlier session. The transport layer may optionally provide the compression. User authentication protocol, which authenticates a user to the server. The connection protocol multiplexes the multiple logical communication channels over a single underlying the SSH connection. Let us see about the particular SSH protocol stack. If you're going to see about those, the three things are three protocols. The SSH transport layer protocol, which provides a server authentication, confidentiality, and integrity, and it may optionally provides the compression. Then the second one, SSH user authentication protocol, which authenticates the client side to the client side user to the server. And the third one, SSH connection protocol, which multiplexes the encrypted tunnels into several logical channels. This SSH is going to be upon the TCP.